Welcome for this new session, a series of masterclass about Autodesk Turbo design, especially for the composite cover box girder bridge. So for this session, I'll show we are already finished to create beam, to create modelization, create deck, modeling the abutment, modeling the piers, and make create the boundary condition, support the bearings, and after we apply some different load, but the time is now to run analysis because we must run analysis to make the structural analysis of the cover box guard bridge. It's very important and be sure to verify some virtual member verification, talking about the live load and load optimization to conclude. We are almost in the end of our session. So to do it, we are already verify our modeling is okay, everything is okay in place. We can go to calculate or our calculate. We have two types of calculation. Actually, for the new update, for the new features of Autodesk Solid Design 2020. 7, we have this parallel analysis is one of the new, but we're talking about after when we're talking about optimization. But if we're going back to for our session, we will go back for app, but when we're going to a report now calculate, we can go to analysis. You can see here for analysis, we have the mesh discontinuities exist, continue with this analysis. Well, for me, it's not a problem. I can go there and verify solving. We have some increase the database memory parameter via option memory. It's very important. I do it by default to show you how you can increase your memory database. So to do it, you must go to option. We can the first of all tension grade. Here we can put 50 and 50. That is okay. And we can go to management memory. You can see by default it's very small because the number of iterations they are very much. So is the reason why you can put for the large model. But this large model, it can take in account almost minus 40 on the 50 load cases. So I can click OK and go back to the calculation and go run analysis. I'm going well, yes, and I go. We can just make verification. We can we must be waiting because it's the number of many iteration for centroid output for first for the verification. We can wait. I make some for a structural design for civil structural engineer. For structural engineer is very is a happy when you starting a modelization from starting and you finish and you make some different load and run analysis without the software give you the message of error. You can see here the compilation of result output membrane node, zero error and zero warming. That's the good news for structural engineers. It means that we have made a good a modelization in respect some condition of modeling. So our analysis is very completed. Which you can do is just to see some results. So let us see some results. So this is the first result, as you can see here. We have the displacement of this the displacement of the joint. We can see here it's very important to know it for the first load case. So we can see here for idle. We can see here there is many kinds of displacement, but which will be verified by when making the deflection shape. We can see here the value, but we can verify here to make for the result. We can see here we can change. We have sorry, not for member. Sorry, I can check it here. So is the maximum only, and that is okay. There is no problem for that. You can see you can see here in for our bridge, the many kinds of the displacement is for this region. So you can see how we can reinforce it when we make some steel reinforcement. Maybe here we can use the you can use from maybe from 32 or 30 millimeter of steel reinforcement structure. So we can see here there is many displacement for this pair on this pier and for our abutment. which make this instability for here you can see here for the graphic is very important, but you can see here there is a many of displacement, but you can verify when you make a verify kind of check. You can see here is in displacement in in Z, in W is that place only, and in X there is no displacement. It can be just for the box open, but for the rotation here only for those members there is no effect of the rotation. There for there is no rotation, and for RZ it's very good. It means for the rotation no member can be rotated, but the displacement is the problem for our case here. We must taking in account and how we can resolve it. So this is for this one, but we will see this wall for a good way. Well, this displacement when we're making the compilation loading optimization. So for hydrostatic, there's no effect only for this abutment. I know why, because there is no boundary condition supported. We didn't make made for this one. I make it by default. So for the tandem span, we can see the effect here of the tandem span here. We can see for the that one and dot one. We can verify for idle. We can see here there is some effect. The weak zone, the weak area is for here. We can see the result for displacement, and so I can see the fatigue. You can see here, so we can verify after verify the load case. I can see supporting reaction. We can see here the many of kinds of reaction for the idle one. You can see the value, but which interests me is the deflection zone. We can see here there is many deflections. You can see here it already shows us we must taking in account how you can make the taking in account of support condition support bearings support the condition of supporter bearings about this plight here. We must take in account of supporter bearings, supporter the condition of bearings, the bearings condition about our abutment. You can see here we can see it can be the displacement between our abutment and our deck bridge, because there is no condition supporter about our deck. You must take in account. I do it by default to show the effect when you neglect it some condition. When as a structural engineer we can see what the problem and difficulty can occur when we are building your bridge. We must taking in account and how we can fix it. We can resolve it and see how the effect we can fix it and make the diminution, reduce the effect. You can see here for hydrostatic. For our hydrostatic, you can feed the effect. We can see, we can zoom. Sorry, you can see here. You can see this the effect only. The weak zone is only the weak area is only for our abutments. It's very weak because there is no supporter bearings about between our deck bridge and our abutment. You can this is the consequences. So other things we can do is other things we can do is to see about the tandem. Our tandem, you can see the effects. You can see the effect for the tandem forces. I click zoom in, zoom out. We can see this is the effect of deformation. You can see. So sorry for the LN2. We can see here the consequences of the for deformation shape, the flex shape. You can see deflection of shape. You can see here for the LM line 2. You can see for this heavy lorry, for the LM3, the fatigue. We can see the effect. You can see here we have the weak zone, weak area here. May all these things is depending of the bearings condition. Supporter bearings be on the abutment. We did not do it. Is the reason why we can see all this instability. So we can change again for the line 3. You can see is there another one. You can see the line 4. You can see the consequences of stability. The LM3 here, you can see that the very problem. You can see here for the half lorry, see the deflection and the instability of that one. You can see all it's depending of how we make the supporter bearings on the abutment. We did not do it. The reason why we can see it, if we have made it, we can see it can reduce the effect of the stability on the middle of the span. So we can check again the footway for footway accident, or the effect of the pedestrian. Here we can see it's not a significant impact, and the footway concentrated. We can see here for the always on the abutment. I do it by default to show when we neglected some things as a structural engineer, some consequences, some consequences which can have for your project when you go to the phase of buildings. So as a structural engineer, it's very important to take into account when we make the structural analysis. This is a case. So the case two is when I'll verify the envelope. So for this one, for the virtual member, for the next session, I'll show you how to take it and verify it. Thank you so much for this session. See you later for the next one.